Hey everyone, welcome back to my channel Leela Web Dev. We will be diving into the big O notation. So let's try to understand. So now it's a correct time to understand what is a big O notation. So we have seen a couple of code, right? So we have seen the couple of code and we'll try to analyze that one. How we can measure the code efficiency and all those things. So now let's try to understand about the super important concept in the programming. It seems a little bit complicated, but actually it is pretty simple once you break it down. So by the end of this video, you will have a pretty good understanding about what is a big O and why we need to use this one and how it will help us to measure how efficient our code is. So now let's try to get started. Okay. Before that, let's try to understand what is a big O notation. Big O notation is a way to describe how the runtime of an algorithm changes as the input grows. Think of it as a tool to measure how fast or slow your code will run when you give it more data. It's like zooming out to see the big picture of your program's performance, ignoring small details like how fast your computer is. So we have seen in our previous example also, when we are trying to give smaller input means, so it is working pretty fine only. When you are trying to give the 1 billion data or something like that, so it is getting break. So that is the thing which I want to tell you. So when you write your code here, so now we understood about this one, right? So now when you write your code, okay, so you want it to run fast, especially if your app gets a millions of users. Bigo helps us predict how your program performs, will handle the larger inputs. For example, if you are sorting 10 names versus 1 million names, Bigo tells us how the time grows. It's a formal way to talk about efficiency. So that is the thing. So Bigo focuses on the worst case scenario, the maximum time an algorithm might take. It's like planning the worst traffic when estimating a drive. So this ensures we are prepared for the toughest situations. So that is the main thing. So here we will be predicting the performance, scalability, and also formal efficiency. So here what I was trying to do, the worst scenario I'm trying to tell you. Focus on the worst case scenario, the maximum time an algorithm might take. So now let's try to see the common examples with the code. Let's look at some common Big O types using the real JavaScript code. We will run these examples and see how their runtimes behave, something like that. So first one is this one. First we have a big O of 1 or a constant time. Constant time means runtime stays the same regardless of the input size. So here this means the runtime stays the same no matter how big the input is. So here we have a function, simple function add up to, that calculates the sum of numbers from 1 to n using a formula. So here we are able to see this one. The function does just three operations. If you try to see, only three operations: multiplication, subtraction, and division. No matter if n is 10 or 10 million, this runtime is flat. So on a graph, if you try to see, big of 1 is a straight horizontal line. So here you'll be able to see it's a straight, the graph you'll be able to see it's a straight horizontal line. It will be. So it is super fast because the input size doesn't affect the runtime. So whatever the input will be, so if it is 1 million, 10 million or something like that, so all the time it will do only three operations, that is multiplication, division, and addition. So that is the thing. So the next one is, so here we can mention this one as big O of 1. So that means it's a constant. So big O of 1 means always it's a constant. So that is the thing which I want to tell you. So next one we have is the linear time. So what is this linear time? Let's try to see. So next we have linear time, that is nothing but big O of n. So here the runtime grows proportionally with the input size. So whenever you are having the input size means it will grow proportionally. If the input doubles means the runtime roughly doubles too. So here I have given the same example, you know already about this example. So now here we are having this one. Now here you'll be able to see the function loops n times. If n is 10 means then it does the 10 additions. So here the loop will continue 10 times. So if n is 1000 means it does 1000 additions. If the runtime grows in the set there, so then the runtime grows in a straight line with n. So now here what you need to do, so whenever the n increases, the time also increases. So that's why we will be measuring with big O of n. So how much the input size is, that much proportionate the code will be. So next one will be, we'll see within another example also. If you want to check it, you can also check it something like this. For example, let's say that you will be having, I will be having simple code. I will copy this one and I will have it in here. Let's say that here I will. So here this one is count up and down. So here what I was trying to do, so I am sending the 5 as an input, and here we are looping the value from 0 to 5, and also again we are looping the value from 5 to 0, if you try to observe carefully. Okay, so now here what we are trying to do, so this function is having two loops, each running about n times. So that means this loop is running 5 times, and this loop is also running 5 times from 5 to 0, and this one is from 0 to 5. So now each running about n times. So here it will be running about n times. Each loop is running n times. So now the big O notation for this one is, you might be thinking that, okay, we can write it as an big O of. So this is depending on the n, and that too it is calculating the 2 times. So here we can tell it as an 2n. So you can tell it as an 2n, something like that, right? But in big O we drop the 2 here. So normally in the big O notation we drop the 2 here and simplify to big O of n only. But because it is still a linear growth. Why? Because if n is having means, so you will be proportionately it will be increasing, right? So that is the thing which I want to tell you. So here big O of 2n or something like that is also one and the same, only big O of n only. So the next scenario which I want to explain to you is the quadratic time. Okay, let's try to go to the quadratic time. Full screen. So you have understood about the linear time. Let's go to the quadratic time. Quadratic time means, so here the runtime grows with the square of the input size. So if the input doubles, the runtime increases by 4 times. So that is the main thing. So here if you try to see the simple example for this one, so you'll be able to see this example. Okay. So now this function has two nested loops, each running n times. So this one is having two nested loops, each running n times. So that means, so if you are so it does means that is nothing but it will do n into n times it will run. So for example, if your n is 2 means, so we will be, the loop will be running this one 2 times and this one is 2 times. So that is total 4 times it will run. So now if n is equal to 3 means, so this one 3 times, 3 times, 3 into 3, 9 times it will run. So if n is equal to 4 means 4 into 4, it will be 16 pairs you will be having, and 16 times it will run. So that means whatever the n you are getting, the multiple time, the square of the times it is running. So here you can write it as in something like big O of n square. So you will be mentioning that one as big O of n square. Why? Because if your input is 5 means 5 into 5 it is running 25 times. So that's why you need to write it as big O of n square. That is why big O of n square can get slow fast. If you try n is equal to 100 means, then it will do 10,000 operations here. So that is the main thing. So that is all about the big O of things. So now here is a key rule. Big O is about the big picture. Okay. We don't care if it is a 5n or 50n operations or something. Just we simply mention it as an big O of n. Okay. So and big O of 2n. So now same thing with the big O of 2n or big O of n square by 2 or something like that. We mention it as an big O of n only. And big O of n square. We are only interested in the order of magnitude, the overall trend. So that is about all about the big O notation. Okay. So here it is a way to measure how an algorithm's runtime grows with when the input size increases. So now we have seen three things. One is big O of 1. It's a constant time, stays flat like our first program, something like add up to, with the formula we have used it. And another one is big O of n. It's a linear time. Whenever the input grows and the program also proportionally, the thing runtime also grows proportionally. And last one we are having big O of n square. So runtime grows much faster with the square of the input size. There are other types also like big O of log n or big O of n log n. So these are all the things we will cover it in our upcoming videos. For now, try these code examples yourself. Play with different n values in a tool like browser console or something like that. But be careful with the big O of n square. Larger inputs like 500 can slow things down, and also even it will crash your browser also. So that is the thing I want to tell you. So that's it guys about this big offense, a basic introduction about this one. So I hope that you found this video helpful. If you found this one, give this video a thumbs up, subscribe and hit the bell icon so you don't miss our next videos. And if you have any doubts or any suggestions, please post the comments below to this video and I will try to give the reply. So that's it guys about this one. Hope you understand about this. Thank you.